I like this section. This section here can save you some time. For some people, they kind of get, it's a little bit hard to grasp. I like the understanding why, and I'm going to try to show why as we do it, because that helps me remember it. But realistically, you could just memorize the equation and be fine. But if you understand why, you're more likely to remember it in a year or a week. So dilation, when you're dilating something, you're changing the size.
Like your eyes.
But not the shape of the figure.
Can you tell us what the can you tell us number 9.3
And you could, she would mention eyes. It's true, you look at the pupil, the black spot in your eye getting bigger or smaller depending on light levels. But dilation, in that case, just means bigger. But so it's proportional. You're going to get two similar figures. And scale factor then, I'm going to put it in red for dramatic emphasis, is going to be the new dimension over the original dimension. Did we do this already this year?
I think so.
I know we're doing it right now in Math 7, so it's kind of fresh in my mind. Couldn't remember if that was you guys or something else. So when we have a scale factor of 3, you could take 3 and change it into a fraction by putting a 1 below it. So you could say that's going to be a 3 over 1. So in other words, the scale factor of 3, our object is getting bigger or smaller?
Bigger?
Yep, bigger, because the new is going to be 3 for every 1 in the original. So if the original is, you could throw in some units like 1 inch high, then the new is going to be 3 inches high. If the original is going to be 2 inches high, then 3 over 1 is the same as what over 2?
6.
Perfect, because you could just do like times 2 to get here, and then times 2. Remember filling in those like charts we were doing last chapter? Mm-hmm. Essentially, that's kind of what you're doing here, that every 2 feet, maybe, switch from inches to feet, every 2 feet on the original is going to show up 6 feet on the new. Make sense?
Yep.
Okay. If we were to have a scale factor of 1/2, this here, now our object is getting
Lower.
smaller or lower. Yep, because we'd have like for every inch on the new, it's going to be 2 inches on the original. So it's only going to be half the size, so to speak. How are we doing? Okay on those? All right, so we have that. Then, so that's not really the big part. Now the big part is more saying, so what's really going to happen to an object if you were to take? So take and do a scale factor to it. So I'm going to write an equation up here in this blank spot. But I want to look at this example first and say, if we have this rectangle, if we want to do a scale factor of 2, is it making it bigger or smaller? Bigger. So now for our width, if this here is my original width, if it's scale factor of 2, its new width is going to be what compared to that? Double, right? So if I try to take and do that exact same length, something like that, might be a tiny bit long. See if I can shrink it a little bit. So that would be like twice as wide. Now the height is also going to be twice as high, agreed? So if we take and do something like this to it then, try to make it a rectangle again. I guess you don't have to fill in the inside, but it might help you kind of see it a little bit. But I should get something that's twice as wide and twice as high. Good? So if we're talking about my original object, I'll maybe switch to a black pen here. I'm going to say that this one here is 2, and maybe the width is probably about 4. What's the perimeter of that original one? If the black sides were 2 and 4. Go for it. 12, yep, because we have 2 plus 4 plus 2 plus 4. So my perimeter is going to be 12. Agreed? Now the perimeter of the new one, this longer length is going to be a 4 and a 4 for a total of 8. The height is going to be a 2 and a 2 for a total of 4. So the new perimeter is going to be 24, right? Because 8 plus 4 plus 8 plus 4. So what do I do to my original perimeter to get my new perimeter, the perimeter of 24? Perfect.
Times the scale factor.
Exactly. So for perimeter, you could say the new P, new capital P for perimeter, equals the old or the original P, capital P, times, can I do a SF for scale factor?
Sure.
Or you could write it out if you wanted to. So you could, for all these different problems, you could try to make up an object that fits the original perimeter, and blah, 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 or you could just multiply by the scale factor. So if you're making something 1/4 of the size, the perimeter will just be 1/4. Agreed? Now, if I take and do area, and I maybe shouldn't have erased that a little bit, but we could just say, okay, I'm going to go with the same drawing. And the area here now is going to be, I think I heard it from somebody, 8? You're going to do 2 times 4 to get the area? Well, now the area of my new one is going to be
16.
32.
What?
Ruh-roh. Which makes sense because I'm not doubling the area, agreed? Do you agree if I doubled the area, that would be double the area?
Oh, you quadruple.
I'm quadrupling the area because I have that original box shape in there, but I have that 4 times. So we could say the new area, new capital A, equals the original capital A times, any guesses?
Perimeter?
Times 4.
Times 4, but how do I
Scale
take
factor times 2,
scale factor times 2?
which means like in parentheses.
Well, maybe let's try this quick a second. Let's see if I can do this on the fly. This isn't in my notes, so sometimes it works well, sometimes it crashes and burns. If I were to take this thing here and say I'm going to try to do a scale factor of 3, do you agree it'd be 3 times as wide?
Yes.
About like that? I need to go 3 times as high, so maybe I'll kind of look at that center triangle. 1, 2. So this is going to be somewhat limited by my drawing ability, but zoop. So now we need to figure out how many of those triangles could we fit in there.
Oh, I
Well,
know what it is.
what is it? You have the number?
It's no, no.
9.
9.
Yes.
So when I have a scale, I probably should have had you guys figure out how to divide it up.
It's
Got it.
1,
times scale
2,
factor
3, 4,
squared.
5, 6, 7, 8, 9. Yep, so when we had a scale factor of 2, we had to make it 4 times the area. Here we have a scale factor of 3. Going from here to here, I made it 3 times as wide, 3 times as high. We have to go to a 9. So it's not scale factor times 2, it's scale factor
3.
squared, because 3 times 3 or 3 squared is 9. 2 squared, 2 times 2 is 4. So then our equation would be original area times scale factor squared. So for perimeter, the new perimeter, multiply by the scale factor. Area, multiply by your scale factor squared. How are we? Okay?
We're good.
Awesome.